We start with the chapter scalars and vector. The scalars, these are the basically the physical quantities are defined into scalars and vectors. So a quantity can be a scalar quantity or can be a vector quantity. For the quantity to be a scalar, it has the magnitude only, and it is given by a specific numbers and units. So example, length, time, temperature or density. And in vectors they have magnitude as well as they have direction. Okay, so in the vectors we have the magnitude as well as a well defined direction for that particular quantity. Example, displacement, we have a we have how much displacement it is, that is we have the magnitude, and in which direction the displacement is, so we have the directions. Now the triangles law of vector addition, we have the vector addition laws for all of them. That is, if two vectors of the same type are represented in magnitude and direction by the two sides of a triangle, then in order that the resultant is represented in magnitude and direction by the third side of the triangle, drawn from the starting point of the first vector to the end point of the second vector. So if two vectors, suppose a vector p starts from point O and ends at point A, and a vector r starts at from point, and a vector a starts from a vector q starts from point A and ends at point B. Okay, so we have the two vectors of the same time represented in magnitude and direction by two sides of a triangle. So we have two sides of the triangle P and Q. Then the resultant is in magnitude and direction is given by the third side of a triangle from drawn from the starting point of the first vector and the ending point of the second vector. So our r vector r is the resultant of this p and q vector. So p bar plus q bar will give you r bar. This is the triangle law of vector addition. So we'll deal with the characteristics of a scalar product and the characteristics of a vector product. So there are different characteristics we have. So I've taken a few. That is the commutative law, which is obeyed in the scalar product, whereas the commutative law is not obeyed in the vector product. That is with p dot q we get p dot q we get pq cos theta, that can be again changed to qp cos theta. But in the vector products we don't have p, we have p cross q, which is not equal to q cross p. So firstly, before going on to forward, the vector or the scalar products are denoted by are multiplied by a dot product, where they have a dot product, and in the vectors we have a cross product. Okay, so the next we have the distributive law, that is the dot product between two p dot q plus r can be p dot q plus p dot r. This distributive law can be simply obeyed in the vector product, that is distributive law becomes p cross q bar, which is equals to minus of q cross p bar. So we get a minus sign when the distributive law is applied. Next is the next depends on the two vectors, the two scalars, the two products, whether it is a scalar or the vector, are parallel, anti-parallel, or they are perpendicular depending on their thetas. So we have pq cos theta. So in this cos theta we'll be having theta 0, theta 180, theta 90, where we'll be getting, if the theta is 0, then the two scalar products are parallel to each other. When it is 180, then they are anti-parallel to each other. That is the answer. The answer will be minus qp. And if the theta is 90 degree, then we say that the two vectors are perpendicular, then the two scalars are perpendicular to each other. Similarly, the cross product of two vectors, if the theta, that is the angle sine theta, between them is 0, then the angle is parallel, then the two vectors are parallel. If the theta is 180, then they are anti-parallel. The answer becomes to be minus of q cross p. And if the theta is 90 degree, then the theta and they are perpendicular, that is p, that the magnitude of p cross q bar, it gives you pq. Okay, so next, if we have, suppose we have a vector p represented by ipx plus jpy plus kpz, that is in all three dimensions. We have the p along the x-axis, y-axis and z-axis. Similar way we have q scalar, then the dot product of the two scalars we have it is in the pattern px qx plus py qy plus pz qz. Similar way, if we have a cross product of two vectors p cross q bar, then in the same way, then we can give the value to be ijk in the form of a matrix px py pz qx qy qz. The value will be, after solving the matrix, we'll get the value of p cross q bar.